Okay, so this graphic organizer goes along with the Envirothon Soils document. And I'm going to blow up and zoom in on different places of it today. But we're going to start out here with what is the definition of soil. And you've kind of got it down there right in front of you. I'll magnify a bit here. So here is soil. Now this is kind of a technical definition. It says that it's a collection of natural bodies on the Earth's surface in places modified or even made by man of earthy materials containing living matter and supporting or capable of supporting plants out of doors. Phew! That's a lot. Okay? So one thing soil is not dirt. Okay? Dirt is like the dust on the floor. If you roll around on the floor and you get dirty, okay, that's dirt. And it's true, if you roll around in soil, you get dirty, right? But we really don't, dirt is not a technical term. Soil is actually an ecosystem. It has living and non-living parts to it that all work together, okay? So if we want to really see what makes soil up, one thing we can do is we can scroll upward in our little diagram here, and you get to the little green place. See how this works like an organizer? And it talks about the components of soil, right? Now these are general components. Different soils, they vary a little bit. But in general, soil is made up of 4 components. The first one is the mineral matter. That's the little bits of minerals, the little mineral particles that make up soil. And we're going to talk about those in a minute here, all right? But 45% of soil is mineral matter. And that's the part that most people think of when they think of soil. They think about the mineral matter, and they forget about the other 3 parts. But the other 3 parts are just as important. Believe it or not, those little soil particles have little spaces in between them. Have you ever gone in the ball pit when you were a little kid at Chuck E. Cheese or someplace like that? You know what I'm talking about, the ball pit? It's got all the little plastic balls in it. Think about the little plastic balls as being like the mineral matter. And then, isn't there all kinds of empty space in between all those balls in the ball pit? That's where the air and the water and the organic matter go, in between those particles. Okay? So air makes up about 25% of your soil, and water makes up about 25% of your soil. Now that varies from soil to soil, and it varies from time of year to time of year. In the spring, you might have a much higher water content and less air because the soil kind of gets saturated with water. And in late summer and fall, you might be drier, so there's less water and more air. So it does vary. But we like to think about the space inside a soil. 50% of it isn't even mineral matter. It's basically empty space that gets filled up with water and air. That make sense? So it's a lot more complex than just dirt, isn't it? And then the other 5% is what we call organic matter. It's things that are living in the soil or were living and are now in the soil. And when we think of organic matter, we can think about macroorganisms. Those are things that are basically big enough to see with your naked eye. So what would be an example of a macroorganism that you might see in the soil? Owen?
Plant.
A plant. Plant's roots, right? The roots of plants are macroorganisms. What's another organism we might find in the soil?
Centipede.
What's that?
Centipede.
Centipedes, insects burrow down into the soil, absolutely. Worms are in the soil, okay? You might even see a shrew. A shrew might dig, or a mole. They dig their way through the soil. That's a very large macroorganism, isn't it? You might even find a woodchuck down there. Dug a hole for himself. Microorganisms are very, very tiny, and by micro we mean you need a microscope to see them. So what's the biggest kind of microorganism you think you're going to find in soil? We've been talking about this in water quality lately as well. You need a microscope to see it, but there's a lot of them pretty much everywhere. Bacteria. Soils are just loaded with bacteria. And you might be thinking, oh, gross, bacteria is in soil. Most of the bacteria in soil are good, beneficial bacteria that help to break down nutrients, break down organic matter so that plants can use the nutrients as fertilizer. Most of the bacteria within a soil are good bacteria. They're not ones that are going to make you sick. They've even discovered that there are bacteria and microorganisms in soil that produce things that are good for people. There are fungi in the soil. And they actually have discovered some pesticides are actually made by microorganisms that are in the soil. And people have figured out how to grow these microorganisms and extract the pesticide. And now we have what we call organic pesticides that come from soils. So when you think of these small microorganisms, you think about things like fungi and bacteria, okay, and even algae in that water on the surface, Owen. All those things are not really necessarily bad things, right? Sometimes they get a bad rap. Most of those are very healthy and beneficial to our soil. If you're looking for a way to remember it, I remember half of the soil is empty space. That's water and air. And the other half is mineral matter and organic matter. That's 45 and 5 is 50, 25 and 25 is 50. Okay? So it's not just a random assortment of mineral particles, it's a complex ecosystem. Also notice that this stuff over here is living, it's alive. So part of your soil is a living, breathing thing. And the mineral matter, water and air, obviously that's non-living. We call this biotic, and these things over here, abiotic. And an ecosystem happens when the biotic parts and the abiotic parts work together to create a system. So soil is an ecosystem, right? It's got living and non-living parts working together. That's what ecosystems are. So far, so good? Okay, now, I'm going to scroll down to here, and I'm going to go over here to what we call soil properties. Okay? Soil properties. These are things that are influenced by how your soil is put together. Not every soil is like every other soil. They all have different properties. Okay? And a very simple one is depth. And depth is usually measured down to what's your depth above the bedrock. Bedrock is sometimes called the parent material. Soil forms on top of rock that was laid down long ago. And that rock has been ground up and broken up, and that produces the soil. So that's why we call the bedrock the parent material. The soil came by grinding up that bedrock, by grinding up that parent material. Okay? So the depth above the bedrock kind of helps to tell you how well formed your soil is. Some places have very, very thin soils that haven't been around for very long. For example, if there's a volcanic eruption that happened recently and it laid down a whole bunch of lava and it left down a whole bunch of that basalt rock, over time that's going to grind up. Water, wind, animals and organisms are going to grind that stuff up and start to make soil. And when things die, they're going to start to add organic matter. It's going to take a while to get a nice deep soil. So the depth of the soil can indicate how long has it been here, okay? And how did it get deposited? Okay, so there's a few other things that we're going to talk about. Over here is what we call soil texture. And there's a whole video on the page there on enviromeed.com on how to figure out soil texture. Okay, I did a whole video on it. But basically, soil texture is how does the soil feel in your hands? And that texture is determined by the 3 different kinds of mineral matter. Remember, mineral matter is 45% of the soil? Well, there's 3 particles that make it up: sand, silt, and clay. Sand is the biggest particle, and it's things that are between 0.03 and 2 millimeters. Anything bigger than 2 millimeters, any little mineral particles, we call that gravel. It's really not one of the soil textures. So if it's bigger than 2 millimeters, we call it gravel. But if it's less than 2 millimeters and down as low as 0.03, we call that sand. And if you've ever felt sand in your hand, it's really gritty, right? Like beach sand. Owen?
I think that's a 5 and not a 3.
Oh, I'm sorry, it's a 5, 0.05. So 0.05 to 0.2, which makes sense, Owen, because the next one over here is 0.002 to 0.05, right? And that's going to be silt, okay? Silt is the medium-sized soil particle. And then the smallest particles, the little tiny ones, are called clays. Clay is anything smaller than 0.002 millimeters. These are incredibly tiny particles, right? But the thing about soil texture is, all it's telling you is how big are the particles that are in your soil. And you can go watch that video on how to figure out a soil's texture to really understand how they're mixed together. But soil is a mixture of all three of these textures. And by the way, the best soil for agriculture is called loam, L-O-A-M, loam. And loam is a mixture of sand, silt, and clay. You need all three of those different textures to give you a nice quality soil. Loam is the ideal soil for agriculture, and it soils with all of those particles in it. Okay, now some other things. We talked about texture, and we talked about depth. The next thing is what we call consistency or firmness of the soil. Okay, so when we talk about soil consistency, we can talk about, how hard is it? Can you take a stick and jab it into the soil easily? How well can you penetrate the soil? Or is it really, really hard packed? Or is it very, very loose? Okay? When a soil is loose and you can take a stick and dig a little hole when you gouge it into the ground, we say that it is friable. Okay? Friable means you can break it apart fairly easily. Right? That's a soil consistency. But sometimes soil is really, really hard packed. And it's difficult to dig in. Has anyone ever seen a soil that was just really hard to dig a hole in? Yep. That's a function of its consistency. All right. Then we can come down here and we can talk about a soil's structure. So structure is if you dig a hole in the ground and you look in the side of the hole where you have dug out, how is the soil put together? So that sand, silt, and clay, how does it clump up? That's its structure, okay? And we have a bunch of different kinds of structure. The first kind of structure is called granular structure. And what we mean by granular, it's like, you ever open up a bag of sugar and you see all the grains of sugar, they kind of fall through your hands? Granular structure is like that. It looks like cookie crumbs, right? In other words, the soil isn't clumped together very, very well. It's got a lot of tiny, loose particles to it. It's a lot like cookie crumbs. That's granular, right? Then we have blocky, okay? And blocky soil is just that. When you look in the soil profile, it looks like it's arranged in big blocks, and it's hard to get them apart, okay? And then we have platy. The soil is in very thin, platy, horizontal layers. Blocky soils, the blocks tend to be vertical. Platy soils, the plates tend to be horizontal. And then we have prismatic, which are long rectangular prisms within the soil column. So these are all kinds of soil structures: blocky, granular, platy, and prismatic. Right? So when we come over here, again, we're talking about soil properties. We talked about texture. We talked about consistency, depth, structure. And then the last part here is called drainage class. Okay, drainage class. And drainage class is how well does a soil drain, all right? And there's a very simple rule for identifying soil drainage. Does anybody know what the rule is? When you look at a soil, what's an easy way to tell its drainage? whether it's well drained or poorly drained. Owen, you remember?
How much water is currently in the soil?
No, actually, how much water is in the soil can vary very, very much during the year, right? In the spring, soils can be very wet, and in the fall, they can be very dry. So how much water is actually there at any one given point of time doesn't necessarily tell you its drainage class. I will say, Owen, it could be a good indicator, but there's a better indicator of drainage.
Like if it's the middle of the summer and it hasn't rained for a while and it's really, really
Yes, that having water in the soil there would tell you something about its drainage, right? If you walk out into a field and most of the field is dry, but you find this one area of soil that's remaining wet, that area is probably poorly drained. So wetness is, that does work. But there's another factor that works whether the soil is wet or dry. It'll tell you how it drains. Drew?
Is it color?
The color of the soil, okay? It turns out when you look at soils, if you see soils that are black or dark gray or silvery, that means bad drainage. And the reason is the iron in the soil is separated from oxygen when the soil is wet all the time. And that causes a black or a gray color in the soil. When you have water that drains through a soil very, very well, have you ever seen when a metal bar gets wet and then dries off, and then an iron bar gets wet and then dries off? What happens to that over time? It oxidizes. And what's the fancy word we use for oxidation like that? When something gets wet and then it oxidizes, what's on the outside of the metal? What do we call that junk? Rust, right? Rust is simply iron reacting with oxygen. It makes iron oxide. And that's what rust is. It's iron oxide. That happens in soil too. In soils, the iron that's in soil, when water drips through it and then dries up, it turns a bright color. It turns to iron oxide. So when you see soils that are yellows and reds and kind of bright brown color, like a Ritz cracker kind of color, those brighter colors, you see bright color in a soil, that means you have better drainage. When you see blacks and grays in a soil, almost always means poor drainage. So remember that rule. Bright colors, you're going to get rusting in the soil, good drainage. When you have poor drainage, it's wet all the time, it doesn't oxidize, you get bad drainage. Okay? So the color is a great way to know your drainage. Right? So drainage class is another property of soils. And again, here's my soil properties. I'm just following all these little lines down. So there's drainage class. The next thing is pH. How acidic is the soil? Now you might be thinking, well, I thought pH was something in water, right? How acid or basic a soil is. Well, it turns out pH, remember, isn't there water within the soil? Right? It's 25 to 50% water in those empty spaces. And that water has a pH to it. We call it the soil solution. It's that water that's within the dirt, within the soil. And pH is how acidic is your soil. Main soils tend to be really, really acidic. It's just the problem that we have. And I'm going to give you a little quick thing here about pH scale. So first of all, pH is capital H, little p. pH is how we say it. And some way to remember that is it's the power of hydrogen. Okay? It has to do with the amount of hydrogen ions in the water. So pH, think power of hydrogen. That's the way I remember it. And when you look at the pH scale, 7 is in the middle. It's neutral. And it starts at 0. And it goes 1, 2, 3, 4, 5, 6, 7. And then it goes from 7 to 14. Anything from 0 to 7, what do we call that? If it's between 0 and 7, it is an acid. Okay, so if you're between 0 and 7, that's acid. And if you're from 7 to 14, you are a base. And 7 is what we call neutral. It's neither acid nor base. Now, one of the reasons why pH is so important to us when we talk about soils is when soils are acidic, the acidity of the soil interferes with plants' abilities to absorb nutrients. The plants can't get the nutrients out of the soil. So some people go out and they spend all this money fertilizing their lawn or fertilizing their garden. Well, if the pH is really low, even though you put those nutrients in the soil with your fertilizer, the plants can't absorb them. Okay? So, does anybody know a way you can elevate the pH and make it less acid? Drew? Lime. Has everyone ever heard of lime, putting lime on a garden or on your lawn? It's a white, powdery material. Sometimes it comes in little tan pellets, but a lot of times it's a white powder. You put lime down, lime absorbs the acid in the soil and makes it less acidic, makes it more neutral. And when you combine lime with fertilizer, that really helps your soil grow things better. So pH is a really important thing when you're doing agriculture. You want to do a pH test, find out what the soil's acidity is, and if it's too acidic, bring that soil pH up. Sometimes you don't really even need to fertilize. Sometimes you just need to add lime and let the nutrients that are already there get released to the plants. But too low of a pH is going to impact those plants. All right, we're moving around here. I think the last characteristic that we have yet to talk about is this thing called, cation exchange capacity. Whew. So does anybody know what an ion is? Owen.
It is a atom or molecule that has gained or lost an electron.
So an ion is a charged atom, right? Okay. And some ions are positively charged because they lost an electron. And other ions are negatively charged because they gained an electron, right? So we have positive ions and we have negative ions, all right? So cation exchange capacity is the ability to hold positively charged ions. In other words, the organic matter and the clay, the little tiny particles in soils, the organic matter and the clays, they tend to have a negative charge to them. Okay, so remember that. Little tiny particles in soil, organic matter and clays, tend to be negatively charged. So when water runs through the soil, if it has positively charged ions in it, those negatively charged ions in the soil will attract those positive ions and hold it in the soil, and then plants can use those things as nutrients. So it cleans your water. It removes those ions from the water. It helps with filtering. Water that travels down through the ground gets purified, and cation exchange capacity is part of that. The negative particles in the soil absorb the positive particles in the water. And oh, by the way, the reason they call it cation, cat means positive. Anion are negative particles.
They may as well have just called it a dog ion.
A cat and a dog ion? I got you on. Well, if you remember, people who own cats tend to be positive people. That's what I've been told. Cat ions are positive ions, right? And so your soil absorbs those positive ions as you go. Right? So we've just talked about here all of the properties of soil. Again, texture, depth, consistency, structure, drainage class, and pH, and cation exchange capacity. And you're going to see all of those things in that soil document. All right? So I'm going to move back up here. Here's soil again. We also talked about the components of soil. And the next thing I want to talk about over here is called soil formation. So this is its own kind of thing in the organizer. Okay, we'll do this one and then we'll take a break from this. So soil formation is, how did the soil come to be? How did the soil go from being parent material, right, being underground rock and stone, that bedrock, and become the soil that it is today? Right? So in Maine, we had this really interesting geological event that kind of got soil formation going here in Maine for our current modern soils. Does anybody know what the geologic event I'm talking about is? Drew? The glaciers. Okay? 12,000 years ago, ballpark, Maine was covered entirely by a giant sheet of ice that was incredibly thick. Okay? Can you imagine that today? Being covered by a sheet of ice, right? People weren't living here. And about 12,000 years ago, the glaciers started to recede. The planet was warming, and the glacier melted. And those glaciers receded back off of the surface of Maine. And when they did that, they kind of, you ever play with the game Etch-a-Sketch? Right? You draw with the little knobs. How do you reset the Etch-a-Sketch? You shake the Etch-a-Sketch, right? And then doesn't everything go away? And then you can take and make a new picture. Well, that's kind of like what the glaciers did. That's the way I think of it. When the glaciers left 12,000 years ago, they kind of reset the Maine soil. They dug it up and plowed it around. They were like shaking the Etch-a-Sketch and started everything over for us. And so Maine soils, our oldest soils, are only about 12,000 years old. Okay? That's all the time they've had. Now, if you go to like southern parts of the country, like Florida or North Carolina, where the glaciers never got to, they have soils that are hundreds of thousands of years old. That soil has been accumulating for 100,000 years. But we don't have anything, and sometimes they call those kinds of soils residual soils, because they've been compiling for so long. Okay? In Maine, our soils are very young. Again, and you say, well, young, they're 12,000 years old. For soil, 12,000 years old is very young, okay? Because some soils can be hundreds of thousands, even millions of years old. But in Maine, very, very young, 12,000, okay? And there are 5 factors that determine how a soil develops into the soil that it is today, okay? And each of these 5 factors, depending on what it does, makes the soil in a location different from other locations. Okay? Every location has its own soil. So the 5 soil forming factors are, starting up here on the top, they're kind of right here, there's 5 lines coming off. The first one we'll talk about is climate. Okay? Are you in a warm climate or are you in a cold climate? Are you in a wet climate or are you in a dry climate? So if you live in Maine, would you consider Maine to be wet or dry compared to climates all over the place? Relatively wet or relatively dry? Owen?
Wet.
Wet. We get a lot of rain, we get a lot of snow. Maine is a fairly wet place. Compared to Arizona, it's really, really wet. Okay? Now there are wetter places on Earth, you know, the Amazon rainforest. But relative to the rest of the places in the U.S., Maine is a relatively wet place. By the way, that's why trees grow so good here. We get plenty of rainfall and precipitation to grow trees. If you go out on the Great Plains, what kind of plants grow in the Great Plains? Grasses. Why do grasses grow in the Great Plains?
Not as much water.
Not enough rainfall. They don't get enough water, so we don't get trees in the Great Plains. We got lots of trees in Maine, so we have a wet climate. And would you say that Maine is warm or relatively cold? We're on the cold side. Now, we're not cold as like the frozen tundra way up north, but we're relatively cold. Okay? So we have kind of a cool or cold and fairly wet climate in Maine. So climate has an impact on how your soils form. Would you expect soil in Arizona to look like soil in Maine? Different climate. So it makes it different. Now, biota are living organisms. So remember, when organisms die and they decompose, don't they put organic matter into your soil? So those living things become that 5% of our soil, that's biota. So yeah, biota can be a a big factor. What living things did you have? What bacteria and fungi and macroorganisms were there? That will help form your soil. The next thing is what we call topography. And it says it's configuration of the surface. So topography is, are you on the top of the hill or are you on the bottom of a hill? Wouldn't that make a difference in terms of the soil? And a good example of that is, doesn't soil tend to erode downhill, right? Stuff flows downhill. So where would you suppose it's easier to grow crops? At the bottom of a hill or at the top of a hill? What's that?
At the bottom.
At the bottom. Because isn't a lot of that soil and nutrients, aren't those things gonna tend to go downhill, right? So there's a basketball team called the Kentucky Hilltoppers. If you're a hilltopper, you're a tough person because you gotta live at the top of the hill and it's much harder to grow your food up there. And then people that own bottom land, people always wanna own bottom land because it's gonna be much more productive because things have washed down into it. So where you are on your hillside makes a difference. How about where your hill is? We call it aspect. Aspect is, how does the sun come into your hillside or into your land? So have you guys noticed the snow is melting right now, right? It's starting to be spring, it's March, right? The snow's going away. Have you noticed that embankments and hills that face south are starting to be clear of snow? Anyone notice this? Driving down the road, you see there are places that the snow is melted. It's all gone. Well, be looking for it because it's happening right now. The south side of a hill is going to have its snow melt faster than the north side of a hill. Why?
The sun's in the south.
The sun, we're in the northern hemisphere, right? Because we're in the northern hemisphere, doesn't the sun appear to be in our southern sky? So if you're on the south side of a hill, you're going to get a lot more sunlight than on the north side of the hill. We call that your aspect with relation to the sun. And if you're on flat land, you kind of get the sun coming in at whatever angle the sun is at. If you're on a hill, so if you're on flat land and your sun angle's like this, you get sunlight. But if you're on a hillside, can you see how you're going to get more sun like that? But what if you're on a hillside that's like this? You don't get as much sun, do you? So your aspect to the sun, are you on the southern side, the north side, makes a huge difference. And as the snow melts, be looking for this. When you look at the south sides of slopes, you will see that they are going to lose their snow first because they get more sunlight. And by the way, more sunlight means more plant growth, right? Better for plants. So topography determines how the plants grow, and it's going to determine how your soil forms. So you on the top of the bottom of the hill, you on the north, south, east, or west of the hill. All of those things are topography, right? Think about topographical map. Where are you on those topographical lines? That impacts your soil formation. Next factor is time, right? Time allows for more weathering of particles. How old did I say main soils are? Very good, Connor. 12,000 years old, right? So are main soils old or young? Young. So have they had time to really, really develop like a soil that's 100,000 years old? No. So that time is a soil forming factor. And then the last thing, I think we've talked about the big four here. We got climate, biota, topography, and time. That's 4 out of the 5. The last thing is what we call parent material. And parent material is, what is the stuff that your soil is actually being made of? And we have a whole bunch of different parent materials, and I'm going to go through them real quick here for you, okay? The first one is organic soil. If you've ever been to a peat moss bog, peat moss, the moss just keeps growing on top of the old dead moss. So moss lives, it dies, new moss grows, it dies, new moss grows, it dies. And when you get peat moss like that, it's all organic matter. There's no sand, silt, or clay. It's all organic, okay? Not a very common soil parent material, but it does happen quite a bit. If you use peat moss in your garden, it helps you to add organic matter to your garden. The peat moss probably came from a peat moss bog. It's all organic, okay? And it will be very, very black and have a nice earthy smell to it. That's another way to help identify it, because it's all black decomposed matter. So very, very black, rich in organic matter soil. Okay, the next one, so that's one of the less common soil types in Maine. This next one is the biggest soil type in Maine. It's called glacial till. And remember I told you how the glacier moved out of here 12,000 years ago? When the glacier left 12,000 years ago, it plowed or tilled the soil. The majority of soils in Maine are glacial tills, okay? And the big way to tell if it's glacial till, look for angular rocks. Angular rocks were ones that are kind of torn up by the glacier and deposited as it tilled the soil over. How many of you have tried to dig a hole in Maine? How many of you have hit rocks when you dig a hole in Maine? Right? Maine is famous for its rocky soils. That's because the glacier tilled it up and it dropped all these angular rocks in our soils. So glacial till has angular rocks in it. And it's the most common one. I always tell kids on the Envirothon, if you don't know what the parent material is, guess glacial till, because most soils are glacial till, but not always. All right, a couple more and we'll be done. The next one is called outwash or stratified drift. And this happens in sand and gravel pits. How many people have seen a sand or gravel pit? Right? Big deposit of sand. What happens is when the glacier melted, a stream of melt water went running off the glacier. And that stream was carrying sand and gravel. And as the stream went by a location, it would drop all this sand and gravel in one place. And when we find these locations, we go dig them up and we use them to get sand and gravel for construction. We put sand on the roads in winter for traction on the snow and ice. We use sand to make concrete with, right? So outwash or stratified drift. And the reason they call it outwash is because the sand and gravel washed out of this glacial stream. That's where the name outwash comes from. And stratified drift, they call it that because stratified means it's in layers. Have you ever seen like a sand pit that cut into the side of a hill and you can see all these nice layers of sand and gravel within the hillside? That's stratified drift. So this is the same thing. Outwash and stratified drift, two names for the same kind of soil parent material. Lacustrine. Lacustrine was sediment deposited at the bottom of an ancient lake. There was a lake there, and sediment kept sinking to the bottom of the lake, and it deposited all this sediment over a long time, and then the lake dried up and went away, and now we have this lake-produced soil. So lacustrine, think lake, L-A-C, lacustrine, lake. I know it's K, but lacustrine lake bottom. Marine sediment is sediment that's deposited by the ocean. Anybody ever been on clam flats? You know those muddy, silty clam flats if you go clamming? You are walking in marine sediment that's being deposited. Okay? So marine sediment is deposited by oceans. Okay? But don't get fooled because there are marine sediments all the way in Skowhegan, Maine. The ocean, back when the glaciers were here, 12,000 years ago, the glacier pushed the surface of Maine, the land, down. So we actually had sea levels that went all the way up. At one point, Jay here was oceanfront property. And we had oceans that made it all the way up to Skowhegan. Came very, very far inland. So sometimes you can find marine sediments in very far away places. There's a sand pit in Skowhegan that's full of all kinds of little marine fossils and shells. It was marine sediment at one time. And then last but not least are what we call alluvial soils. They're deposited by moving water, like rivers. Have you ever noticed that there's a lot of farms along the shore of rivers? Right? That's because every now and then, at some interval, the river floods its banks. So the river goes up onto the land in the springtime, and it drops all this fresh sediment onto the ground. and it makes this wonderful soil for agriculture. So farmers love to grow crops in alluvial soils along the shores of rivers, because that alluvial soil can extend a great distance away from the river itself. You don't have to be right next to the river. When those rivers, over time, when they flood their banks and they drop off sediment, that makes great soil for growing crops. That's alluvial, on the shore of a river. Oh,
Would soil that is composed of eroded limestone be considered a marine soil?
not if the limestone was inland. I'm not sure. It's a good question. But it may, if it happened when the ocean was in, I suppose. Okay.